Thank you for watching the video about synthetic roots in application in the cost of goods program provided by Rondex Pharma. So in this segment, we're going to talk about some of the automatically generated information that comes back from work you've already entered into the cost of goods software. So in this case, we are considering three different roots. Route 9640617, which is, as we can see from the comment, is based from the world patent to make this product. We started the two starting materials, isovaleraldehyde and diethylmalonate, and we work our way up in 1, 2, 3, 4, and then finally a final recrystallization in 4 steps to the final product. Each of these nodes had a lot of useful information on it. So let's go back and we'll look at these more carefully. So, for example, the pregabalin, we know the step, we know the molecular weight of this, we know that the step yield is about 90%, we know the step yield for this one is about 33%. The utilization factor, this means that to make 1 kilo of pregabalin, I need 1.11 kilos of pregabalin crude. And I need 3.3 kilos of this intermediate 3, and I need 7.7 kilos of this intermediate 2, and I need almost 8 kilos of this intermediate 1. So you can see there's a lot of weight going through this process based on the yields of the step. Another very nice feature is we can look at the structures that are associated with each node. So you can see this is intermediate 1. This is intermediate 2, which this is the intermediate. We'll drill into this one a little more deeply. 3, 4, 5, and so you can see what the intermediates are at each step on the way through. Another thing we can do is we show the process as a whole here. So we see all the chemistry for all the steps that we can simply paste in or attach from a JPEG file directly to the thing, so we can see what's going on with it. Another thing we can do, which is extremely useful, is we can drill in. Let's drill into the cyanide addition. We can go in here directly, and we can review the process field. We may or may not be able to make any changes to it, whether we've used this for calculations already. In this particular case, we have, so we can't make any changes, but we can view what's going on in it in some detail. And we can see, for example, that that potassium cyanide is really the limiting reagent here, and the intermediate 1 is used in excess, about 14% by mole excess. So that's actually kind of useful. You can drill in and find out what's going on. This diagram is drawn for you automatically as part of, once you create a process, this root diagram simply is put together directly from information that's already been created in the process. So, for example, I can create a new process, and I'll say a target. The target doesn't have to be the final product. The product can be an intermediate on the way to the final product. So we can look at, for example, what it would take to make compound 8 instead of final product. Of course, compound 8 is just made directly, so that's not very interesting. But say, for example, compound 3 can be the target of a root. So then we can choose which process we want to use to make that, and so on, down to the end. So there may not be many options for making a root. So you can create a root that way, directly from the information that's already been generated. Let's go back to the original root that we were looking at before. I want to show you one other thing that's very handy: quantity calculator. So we have all the information that we might want to know how to make how much material. So let's say we want to know how much to make a metric ton and how much to make 10 metric tons. So we simply put those in and we do the calculations. So it turns out that we need something like 6 tons of diethylmalonate to make 1 ton of pregabalin, and conversely 64 tons almost of diethylmalonate to make 10 tons of pregabalin. This can be output into the common CSV file if you wish also. So you can use this for other calculations, for other purposes in some other place. So this information can be stored and used in other ways. Thank you very much for your attention.